guys, this is Miss Spangler. I am going to give you a shortish lesson on what we didn't get to yesterday, which is how to write a quadratic function when what you're given is 3 points on the parabola. So yesterday we did given a vertex and a point, or given 2 intercepts and a point. And based on what you were given, you used either vertex form or intercept form. Okay, so it's much harder when I don't give you one of those special points. Like yesterday I was giving you an intercept, or I was giving you the vertex. And those would be special points, like important points on the graph. Now I'm just going to give you 3 points on the parabola. So, for example, write a function. Let's say that says quadratic. Write a quadratic. Of a parabola that passes through these 3 points. Okay, so again, think about the fact that right now I don't have anything special. Like, I just know that these 3 points are on my parabola. They could be 3 points right next to each other. They could be 1 point on the side and 2 points right next to each other. I have no idea. I mean, I would if I graphed it, but I still don't know that much about. Usually when you want the parabola, if you're going to write the equation of a parabola, like, think of your options. You've got vertex form, intercept form, and standard form. Well, in the vertex form, I would need the vertex. I don't have it. In intercept form, I would need the intercepts. I don't have them. So what I'm left with is standard form. So that's what you're going to start with here. Is you're gonna use standard form. Okay, now take a second and think about, what do I even have that I can put in there? Like, do I have y? Do I have a? Do I have x? Do I have b? What do we have? We have 3 random points. Okay, remember standard form, the a and the b, they don't represent anything on the graph. They're just numbers that come from the equation. C represents the y-intercept, but they didn't give me the y-intercept. So all I have here is I have 3 x's and y's. I have an x and a y. That would be 1 point. That's an x and a y. I have an x and a y here. I have another x and a y here. Okay, but this is just one equation with 1 x and 1 y. I mean, technically it's 2 x's, but they're the same x. So I can, if I'm going to put in an x, I have to put in the same one, and a y. So what you have to do here is you're going to have to, since these are all the same information, you have to plug them into 3 separate equations. And then you're going to have to solve those 3 separate equations for a, b, and c, because those are the things I'm trying to find so that I can write the equation. And so what we'll be doing here is we're going to write 3 equations, 3 separate ones, by plugging in or substituting each of those 3 points, each x and y, into standard form. Okay, and we'll have 3 equations. The name for multiple equations together is a system. System in 3 variables. Do you remember doing that in our last unit, solving for x, y, and z? That's what we'll be doing here. It's just it won't be x, y, and z. It'll be a, b, and c. Okay, so I'll start with my first point, my first x and y. I can plug in -3 for y. I don't know a. That's what I'm trying to find. So a in this case is actually my variable. I know you're used to x being your variable, but it's now a is the thing I don't know. For that y coordinate, then x is my -1 is my x coordinate. And I'm writing one equation with this 1 point. So that -1 is still my x when I get to the second x. Okay, and I can simplify that a little bit. So negative 3 equals negative 1 squared is 1. So a negative 1 times b is minus b plus c. Okay, and so this would be my equation number 1. Equation number 1. Okay, so I've got one equation. I'm going to write a second one because I have a second point. So for this point, my y is negative 4. So I can plug in negative 4. In this point, my x is 0. I'll plug that in a second time because it comes up a second time in the equation. And then I can simplify this one. This one simplifies nicely. Anytime you have a 0, it just goes away. So my a will go away, my b will go away, and I'll just have c equals negative 4. So I got lucky on this problem in that we have c. So we know what c is now. But we still have to continue because we still have to find a and b. So this, in this case, would be my equation number 2. Equation number 2 won't always come out that simply. Okay, now I take my third point, 2, 6, and I plug in that y and x. Y equals a x squared, my x this time is 2, plus b times x plus c. And I can simplify this. So 6 equals 4a plus 2b plus c. And this one is equation number 3. Equation number 1, equation number 2, equation number 3. Okay, so what do we do when we get 3 equations with 3 variables? We typically have them written all together, so I'm going to do that. It makes me more comfortable. So I'm going to write these 3 equations as a system. Equation 1, negative 3 equals a minus b plus c. Negative 4 equals c. That one's a nice one. And 6 equals 4a plus 2b plus c. I've got my 1. Remember, this is how I like to solve them. 2 and 3. Okay, now think back to chapter 1. I want to solve for a and b and c. In this case, I actually already have c. So our goal is to try to get this 3 variable system down to just a 2 variable system. So just a system that has only a and b in it. There are different ways to go about it. What I want to do, though, is since I know what c is, I'm going to plug in c into the other equations, because then I would get them down to just a and b. So I'm going to start by plugging in c into equation number 1. Oops, I'm going to add 4 on both sides. This is going to be 1. Okay, and then I'm going to do the same in the other equation, because then I'll have another equation with just a and b. So equation number 3, I'll replace c with minus 4. Add that to both sides, I get 10 equals 4a plus 2b. Now, this is a second equation with 2 variables. So a system of 2 variables. So then if I've got a system of 2 variables, I need to find a or b. I want to eliminate one of those. If I want them to eliminate, I'm going to take this first equation and multiply it times 2, giving me 2 equals 2a minus 2b. Because those 2 now will eliminate, I'd get 12 equals 6a. And now I can find my a. So I'm going to divide by 6 on both sides. A would be equal to. And now I had C at the beginning. Now I have A and I need B. So you've got all these equations to choose from to plug A and C back into. I'm going to choose this one right here because very easy to solve. So I'm going to take that one and do. And again, you can choose literally any one, like this one right here that has 10 equals 4. I could use that one, but I pinpointed the easiest one. A equals, and 1 equals, and I'm going to put in 2 for A, because I know that it's 2 now. And I don't know what B is, so I'm going to solve. So this equation is coming from here. And I'm going to subtract 2, gives me negative 1. So b would equal 1. Alright, I have A, I have B, and I had C. I've had C for a while. So remember, I'm going to go back up here. The goal of the problem was to write a function of a parabola that goes through these 3 points. So I don't have a function of a parabola yet, but I got what A, B, and C should be so that I have a parabola going through those 3 points. So now I just need to take those 3 numbers, plug them into standard form. I'm going to go up here where I have this blank space. So my A now is 2, 2x squared. My B is 1, so just plus x. And my C is negative 4, so minus 4. And that would be my function. This is where I'd ask you for questions, but you can't ask me, so hold your questions. I'm going to do one more relatively quickly because this video is getting kind of long. But if you are ready to go and try one on your own, do so. You can stop the video, but you know, I would suggest trying one more. So, 1 second example. Same situation. This is a parabola. Write the equation of a parabola that passes through, and here are three more points. Okay, so again, I'm going to start with my standard form equation. I'm going to plug in each of my points into that standard form equation 3 times. So I'm starting with my negative 1 and 5. So I can put in 5 for y, put in negative 1 for x, and then I'm going to want to simplify that as much as possible, and that'll be my first equation. So 5 equals a minus b plus c. Equation number 1. Okay, then I'll plug in my second point. So my y in this point is negative 1. My x is 0. And I'll simplify that one as much as possible. Gives me negative 1 equals, oh, everything canceled out again. So again, I have c. That's lucky. That's my second equation. And then I'll plug in my third point. 11 equals a times 2 is my x in this case. So I've got 11 equals 4a plus 2b plus c. And that's my third equation. Write them all together if you want. I think it's helpful. I'll put them all next to each other right here. 5 equals a minus b plus c. Negative 1 equals c. 11 equals 4a plus 2b plus c. There's my system. Okay, so again, if you've got the one variable, then plug that into the other ones. You know that c is negative 1. Why would you leave c in there? So I'm going to take the first equation and replace it with negative 1. Replace c with negative 1. So add 1 on both sides. I'd get 6 equals a minus b. Okay. Then I'm going to take the second equation, or the third equation, I'm sorry, this one, and replace that one with c. So 11 equals 4a plus 2b minus 1. Add that on both sides, I'll get 12 equals 4a plus 2b. And now I can write that underneath, and I have a system of 2 variables. Remember when we did this before, it was all about organization. So if this is not the organization that works for you, organize it a different way, but keep your stuff grouped together. These are my three variables equations. Now I have 2 variable equations. Figure out what works for you, keep them labeled, whatever. Now I need to eliminate a variable. I can multiply this one by 2 again. Jeez, this is just like the last one. Won't always be by 2, but it works out because now I get 12, 2a minus 2b. That was a coincidence. So I'm going to get 24 equals 6a. A would equal 4. What do I need now? I need B, so I'm going to take one of these two, doesn't matter which, and plug in what I know A is now, which is 4. So I took the first one. This is coming from there. And solve for B. So 1 equals negative B. B would equal negative 1. So I have B, I have A, I have C. And Y would equal 4A. Nope, no more A. We know A is 4. Y equals 4x squared minus x minus 1. And that's writing an equation when given 3 points. Now you probably can see that you really like having the vertex or the x-intercepts. This is not easy. So here are 2 good examples. There are examples in the book. You probably can find examples online, and your homework is on Haiku. So good luck. See you tomorrow.